Hi. So in the previous video, we talked about nonce, right? And now in this video, we are going to talk about how nonce are useful in mining. And not only that, we are going to also see how actually mining takes place. So let's start. Now, what is nonce? Let us understand nonce first. Definitely, we have seen nonce in great detail in the previous video, but let's see in the point of view of mining. Okay. So nonce is a number that blockchain miners are solving for. And what do I mean by this statement? You will understand once we are once we will go throughout the whole presentation. So just wait for some time. Now, what is target? So target is a number used in mining, which we will see how and why. It is a number that block hash must be below for the block to be added onto the blockchain. Now, what do I mean by this? So in the previous video, we have seen that nonce is a number that can be controlled by the miners, and when the nonce is changed, right, when the nonce of a particular block is changed, the hash of that block is also getting changed, right, because nonce is also being added as an input to our SHA-256 algorithm. And when we are changing the nonce, we are changing the input to our SHA-256 algorithm, so the output that we are getting, that is the block hash, is also getting changed, right? Now, this target is a number that block hash must be below. Now, what do I mean by that? You will understand once we will start with our presentation. So just don't worry about it. But for now, just understand like this, that you have generated a block hash. Okay, you have generated a block hash by changing the nonce. Now, your block hash must be below the target, that is a number that is being adjusted by the Bitcoin algorithm. Let's say that we are talking about Bitcoin blockchain only. So this Bitcoin blockchain will give you a block hash, means this Bitcoin blockchain will give you a target, okay, and you have to produce a hash, block hash, which is below this target. And this will make sense once we will start with our presentation. Now the target adjusts every 2016 blocks. So this is something which is being adjusted after every 2016 blocks, and it also ensures that the blocks are mined once every 10 minutes. Now, this is something which is actually being done by the Bitcoin algorithm, means by the Bitcoin blockchain only. So we are not doing anything. There is no central authority who is doing these things. All these things are being controlled by the Bitcoin software only. Okay. So this is how our hashing algorithm looks like, right? Which we have discussed in one of the videos of hashing algorithm, where we are giving an input to this SHA-256 algorithm, and this SHA-256 algorithm is then just producing this hash, right? This hash, 64 hexadecimal character, that is a hash, right? Now, what are these numbers, right? What is this 5819 EF? So this is an alphanumeric character, right? We have numbers, we have also some characters. So like, what are these? These are nothing but these are actually hexadecimal numbers. So if you are from computer science background, or if you have taken computer in any way, then you might know this, that these are hexadecimal number. So like we have a decimal number system like 0, 1, 2, 3, 4, 5, 6 till 15, right? So these are decimal numbers. And if we have to write the same number in hexadecimal number system, we write like this. So if you will see that 0 to 9, everything is the same, 0 to 9. But after 10, means after 9, when you have 10, so 10 is represented A in hexadecimal, 11 is represented as B in hexadecimal, and 12 as C, and so on. Okay, so this is what hexadecimal number are. So again, if you want to know a bit more about it, just watch any YouTube video, or just go for any Google page, and you will see that it's simple. It's simply a number system. Like we have decimal number system, we have hexadecimal number system, nothing else. Okay, so these are the hexadecimal numbers that you are seeing. Okay, so these are nothing but these are hexadecimal numbers or hexadecimal characters. So let's say that this is one of the hexadecimal number, right? Because as we said that decimal number system can be represented in hexadecimal number system. So this is nothing but this is also a number. Like we have 100, 1000, 999, or let's say 1 lakh, 2 crore, or like 2 crores, 10 lakhs, 99,000. This is also a number, right? In the same way, we have this hexadecimal number. We can have a hexadecimal number looking like this. We can have a hexadecimal number looking like this. Now let me ask you a question, that let's say if you have 64 characters, okay, let's say you have 64 characters, means you have 64 blanks, and you have to find the smallest hexadecimal number. What will be the smallest hexadecimal number? What you are going to fill in those 64 characters, in those 64 blanks actually, so that you have the smallest hexadecimal number. Take a while, pause me for a minute, and then answer it. I hope you have answered it. So let's see. What will be that number? That number will be 000, right? So we are filling each and every 64 blanks that are given to us with 0, and if we will fill it with 0, so the number that we will get will be the smallest number, right? In the same way, if I will ask you that what will be the greatest number, you have 64, again 64 blanks, and I want to know which is the greatest number. What are you going to fill in those blanks? What will be your answer? Take a minute and pause me for a second. I hope you have answered the question, and the answer to this is simple. That will be f y. So 64 f are there. Why? The reason is simple, because in hexadecimal number system, as we have seen, 15, if you will see, f is the largest number currently in hexadecimal number. Like in decimal number system we have 10, right? Like what I'm trying to say here is that in case of decimal number, after this there is a repetition, right? 11, 12, 13, 14, 15, 16, and hexadecimal number is also the same case. The important thing to notice here is just remember this, that f is the largest number, right, in this table, right? F is 15 actually. So we can have f in all those 64 blanks, right? So this is the largest number. Now why I'm telling you all these things, you will understand. So this is our block. Okay, we have some data. We do not have any nonce. Since we do not have any nonce, so we are not we do not have any hash here, right? And this is the set of all possible hashes. So when I'm saying all possible hashes, so what I'm saying is that we have hashes here, means all the hexadecimal numbers here from smallest to largest. Okay, so we will start from 00000, because since we are talking about 64 blanks, 64, because SHA-256 produces 64 hexadecimal characters, so there will be 64 zeros here, and then there will be 64 f here, right? Means between these you will have all the numbers. So you will have something, let me start my pen. So you will have 0000 like this, 0, then 00001, then 00002. I hope you understand, right? And the same way you will have FFF till here. So we have all the possible hashes in this all possible hashes square, okay, arranged from smallest to largest. This is a target that is being set by the Bitcoin algorithm. Now how does why Bitcoin algorithm set these type of targets? As I said, so that it can ensure that each and every block is mined on an average of 10 minutes only. So no miner can mine the block before 10 minutes. And when I'm saying mine, what do I mean by mine? Means no miner can solve a mathematical problem before 10 minutes, on an average of 10 minutes. Okay, so this is to ensure that, and for that we have this target, and this is set by the Bitcoin algorithm, since we are talking about Bitcoin blockchain. Okay, now we are going to see what is that mathematical problem that miners actually solve for. We have seen an overview that miners solve a mathematical problem, and after solving that mathematical problem, we have block created, and then we add that block after verification and validation, right? In the blockchain mining overview, if you haven't seen that video, please check that video in the playlist. You will find that, or I will share it in the I button. Okay, let us see what is the problem that miners are actually solving for. So let's say we have a nonce 100. Okay, so we have a nonce 100, and for a nonce 100 you can see that we have a hash, that is CD1AEFBF. Okay, and this hash is actually belongs to this part of the, all these possible hash, means this is belonging somewhere at this position. Okay, at this position. Okay, now when we will change this nonce, you can see that when I'm changing it to 76, this hash changed, and now we are at this position. An important thing to here notice is that none of the nonce till now that we have generated is below the target. And we have seen, right, in the definition of target, that the block hash that we are generating must be below target, so that we can add a block to the blockchain, or we can create a block. And this is the problem that miners are actually solving for. What they are trying to do is they are trying to change the nonce, because this is something which is in their control. They are changing these nonce. Now once they are changing these nonce, they have different hashes, right? Before that, if you will see, we have 100, like before at nonce 100 we have this hash, at 76 we have this hash. So what they are trying to do is they are changing the nonce so that they can generate hash. And what they are trying to do here is they are trying to generate a hash. They are trying to generate a hash which is below this target. Currently none of the hashes that the miner has generated is below the target. So he will keep on generating these nonce. He will keep on changing these nonce. So let's say he started again and now he has a nonce of 201, but still you can clearly see that this hash is not below this target, right? As you can see from the picture. Okay, now let's say he again changed the nonce and now he has a hash of 000b6a, and this is something which is below this target. Now this is the time where the miner has actually solved the mathematical problem, because he has generated a nonce, not actually I will say nonce, because when I'm saying nonce, so actually nonce is something which is actually generating our hash, right? So when I'm saying nonce or block hash, just think like I'm going to use them interchangeably, so just don't be confused. So when he is changing the nonce, now he has produced a nonce, or he has produced a block hash which is below this target. So now this miner has actually solved the mathematical problem and he will be rewarded with a cryptocurrency. And if we're talking about Bitcoin, so he will be awarded with Bitcoin. Now some of you might be thinking like, why this hash is below this target? Now why not these hashes, right? Some of you might be thinking, and I will explain to you these in much more detail in our upcoming slides. But for now, let me give you a hint. Actually, what is actually happening, if you will see, this is the target, right? 000. This is a number. So we are saying that the first 4 digits, since we have 64 characters, right? We have 64 characters, and in this we are saying that for the target to achieve, the first 4 numbers should be 0, right? The first 4 numbers should be 0. So any number which is below this number, it can be anything. It can be anything. Any number that is below this number will be the desired hash, and the miner who will generate that desired hash will be awarded. Otherwise, if a number, if you will see this number, this B474, this number can never be below this target, right? Why? Because in the starting only it has B474E, right? Since we have taken only 8 characters here, right? 9 characters actually for the demo purpose, actually 8 characters, yeah, 8 characters only. So you can clearly see that all the 8 characters are having these numbers. So none of these numbers are 0. So the target can never below this, the hash can never be below this target. And that's why this hash is the one which was the desired one. But only there can be various other hashes, because this is an area, right? It can have many target. So it can also have a target of, means the target can be right like this also, 1 2 3 4. Okay, because again we have 4 zeros and the number which will be below this. And don't worry, if you still are not able to understand, you will understand it. Let's move on and then you will understand it in a much more detail. Okay, before moving further, let me tell you one more thing. Because some of you might have this question that so this nonce, like the nonce that we are generating, is this producing, like it is so simple, like it looks so simple that we can generate a nonce and we can be here, right? We can generate some nonce and that will lead to here, because you know all these hashes are from smallest to largest. So just generate a nonce which will lead us to this, right? But this is totally a random process. Why? Because if you will see, if we will start with 100, this 100 is producing a hash which is here, right? Which is some point here. Now when we have 76, now you can see that this 76 is producing a hash which is somewhere there, means it is much above the previous one, right? So it is producing a hash which is some point here. And let's say if we have 201, so in that case you can clearly see that it is somewhere below. So this is a totally random process. So this is not something like you can just produce non-sequentially that 0 1 2 3 and you know you will start from this. No, this is not how it works. This is a totally random process. So like you cannot just produce a nonce like by thinking, okay, I will produce this nonce and that will lead me to this, right? This is a totally random process. There is no pattern to it. So just remember this and do not be confused with this. Okay, now let's move on to the detailed topic of this target. Now let us understand that criteria, that target and all those things if you are still not able to understand. So let's say we have a 5-digit number, because as I said, hexadecimal number are nothing but these are also numbers. So we are considering that we have a 5-digit number, and with the help of this 5-digit number we can cover this entire area, right? So we can have numbers starting from 00 till, and let's say we are only assuming decimal number system, so we can have a number of 99, right? So we are assuming that we have a decimal number system for now, not hexadecimal number, so that I can explain you this. So we have a number starting from 000 to 999. So we are covering this entire area, right? We are covering this entire area. But what will happen if I will make the first number 0? If I will make the first number 0, now you can clearly see earlier we were covering from 00 to 9999, right? But now what we are covering? We are only covering these 4 digits because we have made this first character as 0. So now we are covering from number from 00 to 999 since the first character is 0, the first number is 0. So now you can clearly see we have much smaller number, right? We have much smaller number between this range because earlier we were having 99999 and now we have only 9999. So definitely this range will be between this small, like a small range will be there between these two numbers, right? So that's why we are saying that this is actually representing this small area. So this area is actually having numbers from 00 to 99. And that makes sense also because 999 is a much bigger number. So it will be from here to 000, right? It makes sense. And what will happen if I will make the first two characters 0? Again, this area will get reduced. Why? Because now we have only numbers from 00 to 999, right? Because the first two are already 0. The first two are already 0, right? So by this, you can clearly see that the area is getting reduced. And the miners are actually solving for this area only. So they are actually producing a nonce which is lying between these two ranges, between this area. So they are finding, let's say, they have a target of, for example, let's say 00, let's say 453, just an example. So any number which is below this range, like that can be 00452, that can be 004 or 300, anything which is below this range will be the solution for their mathematical problem. Or any number which is above this, let's say for example 12453 or 10453, all these numbers you can clearly see that will lie above this area, right? Because it is only a 3-digit number, but all these numbers are 4-digit number. So definitely we cannot have a number 4-digit number in this area because this is the area of 3-digit number, right? So that's why we have this type of thing, this type of target thing. And I have just given you one more example where I'm saying that first 3 characters are 0. So now you can clearly see one more important thing, that you can see that as we are increasing the number of 0, right? As we are increasing the number of 0, the target area is getting reduced. And when the target area is getting reduced, it will become more difficult for the miner to solve the mathematical problem because now they have to solve for this small area only. Earlier, they were solving for this big area. Before that they were solving for this big area, but now as the number of zeros are increasing, right, before these two numbers, the target area is also getting decreased, means the solution is the probability of finding their solution to their problem is also getting reduced. And that's what make mining very much difficult. And just don't believe me, just don't trust me, I will show you a mathematical proof for this also. Okay, so just if you are comfortable with mathematics, then that's good. If you're not, just have a look at it. You will have a good sense why this is so much difficult for the miners, because many of you might be thinking it looks so easy, we do not have to do anything, we have to just generate, we have to just generate some nonce, and with the help of which we can easily find the block hash, and that's an easy process. But that's not an easy process, and you will understand this with the help of this example. So let's say this is the current target. Definitely this is not the current target. I have made this PPT a long back. So just say that this is one of the target that was given to the miners to solve for. So now the miner's responsibility is to generate a hash which is below this huge number, right? And the first 19 characters, as you can see, are leading 0. Okay. So now let us understand this, why mining is so difficult. Okay. So let's say we have a possible hash, means we have 64 hexadecimal characters. So we have 64 hexadecimal characters, right? And so in total, we can have a possibility of 10 to the power 77 hashes. Now, what do I mean by that? So since we have 64 characters, right? So in these 64 characters, I have 64 possibilities, right? 16 possibilities here, 16 possibilities here. Why 16 possibilities? Because as we have seen in hexadecimal number, we have number from 0 to 15, and if you will count, it is 16. There are 16 numbers, right? 0 to 15 means, or 0 to f actually, 0 to f. So we have 16 numbers here from 0 to f. 16 numbers are there between 0 to f, and that's why we have 16 possibilities. So we can have 0, we can have 1, we can have, you know, a or b or f, like this. This is something related to permutation. If you are not comfortable with it, that's fine. For now, just think like this, that we have 16 to the power 64 possibilities, because 16 into 16 into 16 till 64 times we will have 16 to the power 64, and we have calculated in 10 to the power 70 into 10 to the power, so it is 10 to the power 77. Now total valid hashes, because as you can see that the target that is set has 19 leading zeros. So the total possible hashes with these 19 leading zero is 10 to the power 54. Why? Because the first 19 characters are 0, right? First 19 characters are 0, so we cannot touch them. So there's a 0, there's a 0, like this. We can only touch the remaining, that is 64 minus 19, right? 64 minus 19 characters we can touch, so we can say that they are 10 to the power 54, that is 16 in to the power, if you will calculate it will be around, I think 45, right? It is 16 to the power 45, and if you will find it in the form of 10 to the power, it is 10 to the power 54. Now if you will see the probability of picking a random hash, from this large area, that is 10 to the power 77, this is the large area, right, having all the possible hashes, and this is the small area having a small set of hash, right? So if you will see the probability of finding a particular hash that is a solution to your problem, that is 10 to the power minus 23, that is 0.000000 till 22 times, right? Something like that. So this is a very small number. And that's why miner has to put so much effort in order to find a solution to their problem, in order to generate that right hash which is below the target. Now this is the problematic thing, right? So mining is not an easy task. That's why it took days. If you're a miner of proof of work, it took days, even weeks sometimes, to find the target, to find the desired target, so that you can create the block of a blockchain. Now again, I hope you have understand that. So this is something which I thought you should know, that who is actually adjusting these difficulties. So this is done by the Bitcoin algorithm only. So we are not doing this, no central authority is doing this, everything is done by the Bitcoin algorithm only. Okay, I hope you like this video. If you have liked this video, please click on that like button, and I'm regularly going to upload new blockchain courses on this channel, so please subscribe to my channel. And if you want to talk to me directly on Instagram, you can communicate directly to me on Instagram, that is 4liter21. And you can also join our Discord community of blockchain developer. Currently we have 2000 plus blockchain developer in our blockchain developer community. You are also welcome. So meet you soon in the next video. Take care. Bye bye. And yes, if you have any doubts, please comment below.